When we looked at this graph before, we talked about the concept of left and right hand limits without really framing it within that vocabulary and that notation. So now we want to revisit each of these points that we looked at before and now consider this limit notation and what we can answer about these questions. So we'll start off by looking at the limit as x approaches -1 from the right-hand side of f of x. To do that, we'll look at our function near x equals -1, and that plus tells us that we're approaching from the right-hand side. So we'll get closer and closer to that function value of, in this case, 4. Then we'll consider the limit as x approaches -1 from the left-hand side of f of x. Again, we can trace along the curve, in this case approaching from the left, as we get closer and closer to x equals -1. And we're approaching that same function value of 4. Since those two one-sided limits are equal, that tells us that the limit as x approaches -1 of f of x is equal to 4. If the two one-sided limits are equal, the limit as x approaches that value is equal to that same result. Now let's look at what happens in some of the more interesting cases where we have these discontinuities. First, we'll consider at x equals -4, near x equals -4. We want to consider the limit as x approaches -4 from the right. So as we approach -4 and we're tracing along from the right-hand side, we're approaching a function value of -2. As we consider the limit as x approaches -4 from the left-hand side, again, we see we're approaching that function value of 3, like we talked about before. Since those two limits are not equal to each other, then we would say that the limit as x approaches -4 of f of x equals dne, or does not exist. We can end up writing that out a lot, so we have that shorthand notation to speed that up a bit. So if the one-sided limits are different from each other, that means the limit at that point does not exist. We'll look at what's happening around x equals 2. Again, considering the one-sided limits. First, we'll approach x equals 2 from the right. We're approaching a function value of 5. And as we consider the limit as x approaches 2 from the left, we're approaching a function value of -1. The one-sided limits are different from each other, and that means that the limit as x approaches 2 of f of x does not exist, or dne. Now we'll consider the one-sided limits at x equals 4. Approaching 4 from the right-hand side has us approaching a function value of 2. And as we approach 4 from the left, we're approaching that exact same function value of 2, which in this case tells us, since those two one-sided limits are equal, that the limit as x approaches 4 of f of x is equal to 2. And keep in mind that occurs even though the function itself is undefined at 4. So our function is undefined, but the limit still exists, because even though the function never hits that function value of 2, as we approach from each direction, we're getting closer and closer and closer to that value. So when we talk about limits, we're always interested in what value we're getting closer to, even if we don't hit that point itself.